Welcome to the healthaibrief, breaking down the AI shaping our world one concept at a time. We've spent the last few episodes deep in the engine room. We've pulled apart the mechanics of machine learning, weights, biases, loss functions, and gradient descent. So we now hopefully know how these systems learn, but knowing how a combustion engine works doesn't explain the difference between a Formula One car and a patient transport ambulance. They both use cylinders and pistons, but they're engineered for entirely different clinical terrains. In the recent episodes, we established that AI is simply an optimization machine trying to reduce error. That's the physiology of AI. Now we're going to move on to system architectures. Think of this as moving from cellular biology to systemic anatomy. In medical school, you first learn how a cell functions, mitosis, protein synthesis, metabolism. That's what we've just done with neural networks. But you can't diagnose a patient knowing only about mitochondrial physiology. You need to understand organ systems, the cardiovascular system for flow, the skeletal system for structure, the nervous system for processing. A neural network is just a pile of raw neurons until we arrange them in a specific shape to solve a specific problem. And over the next few episodes, we're going to tour the who's who of these model architectures. We'll look at things like convolutional neural networks, or CNNs, the eyes that AI read our x-rays with, or dermoscopy slides with. We'll look at recurrent neural networks, or RNNs, which process sequences like ECG traces or patient histories. And finally, we'll arrive at transformers, the architecture that underpins the large language models currently revolutionizing a lot of administrative and documentation functionality. Understanding these architectures demystifies their potential errors. When you know that a CNN looks for visual textures, you understand why it might mistake a skin marking for a melanoma. When you know a transformer predicts the next word based on probability, you understand why it might hallucinate a reference in a discharge summary. We're moving from the theoretical to the practical structures that you may well encounter as these technologies mature.